Hi, my name is Andrea Goyen, and I am the Environmental Literacy and Sustainability Coordinator at the San Mateo County Office of Education. In this video, I'm going to show how you can make a wicked problem visible by using systems diagramming. And we'll start off by, of course, defining what a wicked problem is and then getting into some of the tools for diagramming. So when it comes to wicked problems and understanding them, I think the key to know is just that these are the problems that are like so big and so challenging because they're interdependent, because sometimes they're like incomplete problems, sometimes they're difficult to define, but either way, like they're the big ones that we often think of, like disease and war and crime and addiction and things that we just like see time and time again that we haven't yet been able to solve. Sometimes we have solved pieces of it or we've solved some of it, but it hasn't gone away. And typically, solving a wicked problem requires a really deep understanding of the stakeholders involved and, of course, the relationships in between them, which is why analyzing a wicked problem with a diagram can sometimes be really important. So when you look at a traditional problem, yeah, there could be a couple different lines and it might be a little, complex, but a wicked problem, there's just like so many different pieces. And a lot of people like to use the iceberg model to talk about how to analyze a wicked problem, which I think is a really fantastic model because what it forces you to do is to really think about, okay, let's look at all these different layers within these problems. So oftentimes analysis will just stay right here at the top where people are just looking at the events and they're just thinking like, what is happening? And they just kind of stay right there looking at those events over and over again. But it's really important to go a little bit deeper and talk about, well, what are the trends and patterns that are happening over time in this problem? And oftentimes we'll do that analysis and we'll do it through like a written paper. And we'll show like claim, evidence, reasoning. Here's what's going on. It's really important when you're looking at a wicked problem to go one layer down and say, let's understand the structure of this system. And let's look at all the different parts and how they are connected and how they're, what's influencing those patterns, what's influencing those relationships. And of course, there's an even further layer of analysis that we recommend, which is to look at the mental models driving the structure of this model. But we'll get to that in a different video. So in analyzing wicked problems, we want to, yes, say, great, it's good to have traditional thinking, but what we really want is systems thinking in this situation. And systems thinking is just what we're doing here with this iceberg model. So what are the stages of wicked problem analysis? Usually you'll take people through some sort of problem identification. You'll say, here's what we think the problem is. Let's look at that story over time. So that claim, evidence, reasoning. But now we're going to add these new elements of making the problem visible and doing some mental model analysis. Typically, if you're going to do this work, you're going to then move into solutions, right? That's the exciting part of looking at and analyzing a wicked problem is like, how do we actually find solutions? But in order to do that finding solutions, it's important to make the problem visible so you can really look for what are the best places to intervene in this challenge or in this system. So there's a lot of options for making a wicked problem visible. And we're going to do some skill building in this video to understand like, what does it really look like? And when you're doing a systems diagram, you want to identify variables. These are like the components or elements, and we'll talk about that in a little bit, but you want to identify variables that you can put in some sort of diagram, and then you show the relationship between them. So there's lots of different options. These are just three basic options. One is a mind map, one is a cause and effect diagram, and one is a causal loop. And I shouldn't say it's basic because causal loop does kind of push us to the next level of not just basic, but these are three great ways to get started. So I'll talk about mind maps first. I think mind maps are a great tool for organizing and grouping, clustering ideas. So you can see here, even in this little mind map, it says how to mind map. So one thing is to think about style, and then off of style, you'd say, yeah, you can have fun with it. You can do some emphasis. You can make it beautiful. You want to use lines when you do a mind map, and you want to think about the thickness of the lines and the connections between the lines and the length of them, and do they have dots along them? If you're going to use paper, you want to think about what's the right direction of your paper, what's the right color of your paper, how big is your paper, right? So these are all different things that connect to these root concepts as you look at a mind map. And you can totally do this by taking a wicked problem and clustering different issues around it. Another type of diagram is just a cause and effect. And typically when we see cause and effect, we usually just see like just the first layer of cause and effect. But what we want to do is go a little bit deeper when we're talking about a systems diagram or a wicked problem diagram. So we want to go causes of causes, and then even the causes of causes. And you can imagine you could just keep on going back, right? And then on the effect side, same thing. You want to do the effect of the effect and the effect of the effect of the effect. Now, what we find often when we're talking about wicked problems is that these issues typically have circular cause and effect, which is why we advocate for people to think about using a causal loop diagram, which shows that circular cause and effect. Now, in the circular cause and effect, I'm just going to go back really quick. You're not going to have every single one of these effects loop back to a cause and have these reinforcing loops, but you're going to have a couple of them, right? So when we think about it, I'm just going to give the example here around anxiety. So here, if you were to tell this problem, right? As my anxiety goes up, my mistakes go up, and that this means I'm more anxious during a test. So then I start to make even more mistakes. So then my anxiety continues to go up, right? And it becomes this reinforcing loop. But when you think about finding a leverage point for change, the leverage point that you want to push on is that stress level, right? So if we can say, how do we reduce the stress level? Well, we might need to implement a new solution, which might be relaxation exercises. And that will bring us into a balancing loop. So we'll look at a more complex causal loop diagram in a little bit that really gets to the heart of that cause and effect. These ones here were very simple. So making a wicked problem visible. Let's do that with climate change, because that is definitely a wicked problem. So this analysis comes from a student example of students who were 11th graders in high school. And they told this problem and story. So they said, here's the story and the problem of climate change. The Earth's climate is changing and getting warmer due to humans adding heat trapping greenhouse gases to the atmosphere. Now here comes the effect part. Because these things are linked to the climate, warmer temperatures are causing changes around the world. That's dangerous to people. So this is really simplified here in the problem statement, but then they get really into the analysis. So they show the difference between the natural greenhouse effect and human enhanced greenhouse effect. They show evidence of how this is shifting over time. So they show the global temperature going up, the decades of warming that we're experiencing. They show the connection to carbon dioxide and the global emissions of greenhouse gases. And then they also show the impacts that we're going to be facing. And they show sea level rise, and they show the impact on biodiversity. So a lot of really credible evidence that is well researched and has good reasoning here. So now their task was to make the problem visible. Now this group thought about how to do it in a number of ways. So the first thing they did was they went back and they read that story and they read their evidence and they listed out all these variables. So they said, okay, in our story and in our evidence, we've got energy from the sun, we've got greenhouse gases, we've got burning fossil fuels, we've got glaciers melting, we've got sea level rise. They added like, oh yeah, we talked about extreme weather, we talked about freshwater supply, we talked about thawing permafrost. So they have all these different variables or components or elements, whatever word you want to use. It's like the pieces. They got all these and they listed them down. So they read their own story and they read their own research and then they listed it. The next thing that they thought about doing, and they practiced it, is they thought, let's make a mind map. So they clustered things, like they clustered things for emissions. They clustered things for resources and carbon sinks. They clustered the topics that fit under impacts. And then that's how they made a mind map. Now, as you can imagine, a mind map was somewhat limited in really showing the relationships between everything. It was a great starting point, but they really needed to go further. So then the group thought, okay, let's do some cause and effect diagramming. So they first looked at the variables that were causes, and they took all of those variables and they put them onto one side of the diagram. They said, okay, there's causes of causes, there's causes of causes of causes. And then they did the same thing with the effects, right? So they thought about, well, one of the major effects is temperatures rising, and then that causes the glaciers to melt. So they really did think through all the different pieces. But then they realized, you know what, I think there's some level of circular cause and effect. Not a lot, but some level of it. So they thought, let's try to show how that works. So here's basically the way that the causal loop diagram works. For example, if you said we're going to have like the increase of the number of landfills goes up, the methane gas release goes up. As the methane gas release goes up, greenhouse gases go up. So you're showing that with these little positive relation. This little positive shows that it's like if this one goes up, then the other one goes up. If it was a negative, it would be an opposite relationship. So as burning fossil fuel goes up, carbon dioxide release goes up. And as that goes up, greenhouse gases trapping energy goes up. Now let's get to the effect side just to make this a little bit more clear where we start to get this causal looping. As greenhouse gases trapping energy goes up, we start to see surface temperatures go up and we start to see glaciers melting go up, right? From that, you've got even more effects that happen. So as glaciers melting goes up, the sea level goes up. As sea level goes up, land in an area, particularly coastal areas, starts to go down. So now you see that little tiny negative that says, you know what, that's going to have this opposite effect on it. Or over here, let's talk about if we have the glaciers melting, we're going to have an impact on land animal extinction. Down here with surface temperatures, we have an effect on drought. So as surface temperatures go up, drought goes up. As drought goes up, freshwater supply goes down. Over here, we've got surface temperatures go up, ocean temperatures go up. As ocean temperatures go up, ocean animal extinction goes up, right? So you can see, oh gosh, these are some really dangerous things. Now here's where we have a really important loop. As surface temperatures go up, thawing permafrost goes up. As thawing permafrost goes up, carbon dioxide release goes up. And as that happens, greenhouse gases trapping energy go up. And so you get this reinforcing loop. So now you can see why it might be important to go from having just a standard cause and effect to a causal loop diagram that wraps things around it. So here's a kind of their final version of it. And you can see that this is not a perfect diagram, right? Like even as I'm saying it here, I can see, oh, well, it might've made more sense to have the glaciers melting coming off of the surface temperatures or whatever, but this was their version, their draft, and it makes sense overall as you start to look at it. And of course, they also added this global war and regional war. And I remember students doing this presentation, they said, well, as regional wars go up, like they didn't put it on here, but they said, well, human death will go up. And as human death goes up, then they were like, well, I guess you would put a loop over here that says landfills go down. And that's like, we were like, yeah, that's it, right? But that's not how we want to have these solutions. So the idea of making your wicked problem visible is to say, let's avoid that as our solution over here. And maybe over here, we could just reduce the amount of landfills we have by doing other things, or we can reduce the amount of burning fossil fuels by doing other things. So instead of having this horrible negative loop that has to do with human death and suffering, maybe we could just switch to solar and switch to renewables instead of having all that. So that's the point of making something visible, is to really try to understand the relationships differently than you can get in a paper. Yes, of course, you can do this in a linear paper, but sometimes it really helps when it's a wicked problem to make it visible and really understand what's happening there. So now it's your turn. What you're going to do is you're going to diagram out your system or your problem. So I highly recommend doing what those students did first, where you, step one, read through your story and your evidence graphics and make a list of variables. Then try to start with maybe a mind map and cluster them. Then maybe move to trying out a cause and effect diagram and do that kind of like cause of cause of cause, situation, effect, effect of effect. And then look for where might there be some circular stuff going on, where an effect actually leads to a cause or cause leads to more effects. Now, tips to consider when you're doing this: highly recommend listing your variables together when you're in a group. That way you get a chance to really think through, okay, what did you hear in the story? Okay, you came up with that. That way you all have a common list. But then I recommend trying to do some sort of diagram individually first. And I recommend doing it on paper because there's going to be a lot of erasing and a lot of shifting things around. There will, again, just to go a little further on that, there will be a lot of drafts. Typically, when you make a diagram, like you can imagine even like 5 to 10 different drafts of this. So start on paper, share it with the group, then move to a virtual space where you can do it together. One other thing we recommend as you move into causal loop diagramming and cause and effect diagrams is to keep your variables neutral. So what do I mean by that? Let me go back for a second. You can see here that it doesn't say more landfills or more burning fossil fuels. It just says burning fossil fuels. And the reason for that is you want to be able to go back through this whole diagram and say, well, what would happen if we burn less fossil fuels? So if burning fossil fuels goes down, then carbon dioxide release goes down. So it allows you to read your diagram in 2 different ways. So first way is burning fossil fuels goes up, carbon dioxide release goes up. But second way would be burning fossil fuels goes down, carbon dioxide release goes down, greenhouse gases trapping energy goes down. So that's why you keep things neutral as possible. That's a hard thing. And if you need some help with that, let's get some coaching for you. The last thing is explain your clusters or loops verbally to check for accuracy. As I just kind of read through it with you, as I was like reading through, oh yeah, surface temperatures go up, land animal extinction goes up. When you read it out loud, you'll start to recognize, well, maybe there was some sort of in between, right? So maybe as surface temperatures go up, amount of food available to, or desertification goes up, and then deforestation, or then something else, and then land animal extinction. It might be a leap to go from one to the other. And when you say something out loud, people will hear that that missing thing is there. So that is the steps of what to do. Definitely reach out if you need some coaching help. Just want to give you a couple visuals of what like example early drafts might look like. So here might be like an early type of mind map draft where you can see like people just put down ideas and then they clustered them together. Or over here, you've got like a couple early examples of arrows coming together. Over here, you've got how like, yeah, let's start to draw all the lines. And you can see it gets really messy. And that's why we recommend a number of drafts. So good luck to you. Don't hesitate to reach out if you have questions.